In this video, we're going to derive the formula for the arc length in polar form. But before we do that, cast your mind back to the arc length in parametric form. So remember, in parametric form, it is a time that drives everything. So let's say at time t1, the particle is here, and then at time t2, the particle is here. Because of the nature of parametric equations, we can always find, for any given time, we can always find the x-coordinate, we can always find the y-coordinate. So in parametric form, a small change in time, that's from here to here. A small change in time would result in a small change in the x direction. A small change in time would also result in a small change in the y direction. And then from this, we can work out ds by using Pythagoras. So it will be delta x squared plus delta y squared, take the square root. That will then give us ds. So we would then take the limit as delta t tends to 0. Well, as delta t tends to 0, then this becomes dt. And then a small change in time would result in an infinitesimally small change in the x direction, and then also an infinitesimally small change in the y direction. And then from this we can say dx squared plus dy squared square root. That would then give us ds. So another small change in time, would result in another small change in the x direction, and then it would also result in another small change in the y direction, and then we can also work out another ds, and then we would then sum up all the ds's. So we would take we would then sum up all the ds's, so that by using that method we can work out the actual arc length in parametric form. So now we can use the same technique, but in polar form. So remember, in polar form, in parametric form, it is a time that drives everything. But in polar form, it is the angle that drives everything. So the angle is changing about. So no matter where the angle is, we can always find the radius. We can always find the radius. So in polar form, it is the angle that drives everything. But no matter where the angle is, we can always find the radius. So when the angle is here, we know the radius. The minute we know the radius and the angle, then we know the x-coordinate. So the minute we know the angle, from this we know the radius. Well, if we know the radius, then we can work out, we know the precise x location. The x location would be x the x location would be x equals f theta cos theta, and then we will also know the y location. The y location will be f theta sine theta. So, well, I will continue in the next video. Okay.